In just 7 minutes, we'll learn about 3 different ways to get data within your Web3 application. There are a lot of options when it comes to handling data in Web3. From simple RPC calls to subgraphs to even various third-party data APIs like Covalent, there definitely isn't a lack of options. Now, how do each of these methods of reading Web3 data differ? To answer this question, we'll need to first come up with a tricky scenario to understand the strengths and weaknesses of each option. In this case, let's do some liquidity pair indexing with PancakeSwap. So the mission here is to list all PancakeSwap liquidity pair creations in just the past 15 minutes. Now, doing this in practice will look quite different for each option, but as a result, we'll get a clean comparison of efficiency, at least for this specific task. So let's start with RPC calls. This is of course the most traditional method of data fetching. So to start, we want to import Web3. This is the only package that we're using in this case. From Web3, import Web3 and HTTP provider. We'll need to define our Chainstack endpoint. Let's go ahead and quickly spin up a Chainstack node so that we can fill in the string. All right, so we have the Chainstack console open. So we'll head into our project, join a new network, select BNB chain. We'll choose the mainnet. We'll be launching a global Elastic node, so we can leave this all default. As you can see, it's instantly deployed because again, this is a worldwide hosted node, so we don't need to wait for it to sync or anything. So we can just hop right into here and grab my endpoint. All right, so now we can throw the node that we just created into this string compartment here. Now we can move on. Of course, here we want to define a Web3 variable that initializes the HTTP provider. So let's do that now. Provider, and then our Chainstack endpoint here. All right, so now we've initialized our RPC endpoint with the variable W3. Okay, so next we'll need to define a contract address and a contract ABI. In this case, we can just create a variable called contract address and set it equal to the PancakeSwap factory v2 contract address. And we'll also need to define an ABI. This is the ABI of the contract address that we initialized above. I basically just grabbed this directly off of Etherscan, so we can paste that in there. So now let's initialize the contract object with a variable just called contract. And w3.eth.contract. The address is equal to contract address. The ABI is equal to contract ABI. And then we'll need to define a block range here. So we can just do block equals, this will be the latest block, which is w3.eth.block number. And then we'll also need to define a variable for the block from 15 minutes ago. So we can just name this block 15 minutes ago. Now the reason this is minus 300, this is a little bit of an approximation, but the block time, the average block time on BSC is about 3 seconds. So through a little bit of arithmetic, basically subtracting the current block by 300 will get you the block from approximately 15 minutes ago. And then we can also define an event filter here. We can have this as contract.events.pair created. This is the event that we're looking for. And we can create a filter. The from block will be the block 15 minutes ago variable that we just defined. And the to block will simply just be latest. We now want to get everything that this filter finds, which we can just do with events equals event filter get all entries. And then we can loop through the events and just print them out. And then we can just go ahead and run it. So you see we get this huge amount of items, but we have token 1, the pair ID, token 0, the event name, the log index, transaction index, the transaction hash. So this one should be between 13 and 15 minutes ago. So let's throw this into a block explorer and check it out. So this is the first item on the list that we saw. You can see 14 minutes ago. We can check the logs here and see it interacted with the smart contract. And those are the 2 tokens that we can see on here, 0x6c and 0x6c. So this is pretty detailed. It can take a little bit of coding. It's not the fastest way to do it, but it works and it was pretty simple. Subgraphs are an extremely powerful technology that allows you to index information just like this with a high degree of customizability and control over the information that you get and how you index it. So in preparation for this, I built out a very basic subgraph that just indexes the basic information that you could find from a pair created event. But doing this will be super simple. It'll just take a few lines of code, so let's jump into it. So let's first import GraphQL, and let's import time. Okay, so first let's quickly define a variable that calculates the timestamp from 15 minutes ago, and let's define the URL of our subgraph. As you can see here, I already have the subgraph deployed, so we can head into here and grab the query URL. So then we'll need to define our transport variable, as well as our client variable. And now we can go ahead and build out our query. And we'll create an instance of the GraphQL object. And here I'm going to paste in my query. The query here is pretty simple. It gets the first 100 pairs that's ordered by create@timestamp. It's in a descending order where create@timestamp is equal to the timestamp 15 minutes ago variable that we defined up here. Let's now execute the query and print the response. So let's now run it. And you can see here, we have a much more concise response because I'm actually only asking it for the token IDs, create@timestamp, pair ID, stuff like that. So the way that it's formatting its response is just through the ID, token 0, its ID, token 1, its ID, and the timestamp in which it was created. All right, now let's go to our final data fetching method through third-party data APIs. In this case, we're going to use Covalent, which is natively available through the Chainstack marketplace. And specifically, we're going to use the Chainstack Covalent integration SDK. All right, so let's jump into it. Let's start by importing our libraries and defining our key variables. In this case, we're going to import Web3. We're going to quickly define the Web3 variable and use an RPC node. For this, we can throw in the same node that we created earlier. And we can define our Chainstack API Covalent integration SDK. Let's now define the Chainstack API object itself. And here what we'll do is throw in the platform API key of a Chainstack account that has the integration installed. And now let's create a function called getLPCreations. This is where we're going to get our block numbers, define the parameters, and call the actual method on Chainstack API. So this will be an asynchronous function. We can start by defining the current block number. Now we can go ahead and define our parameters. This will include things like chain name, contract address, the starting block, and the ending block. For chain name, this will be BSC mainnet. For contract address, it'll be the same one that we've been using. For the starting block, this will be the block from 15 minutes ago. We're going to make the same assumption as last time and assume that each block is finalizing in about 3 seconds. So we'll just do the current block number and then minus 300. And the ending block will just be the latest block. We can now call the method on the Chainstack API object itself, fetch log events. Then we can throw in our parameters. And now we can log this result. And we're actually going to call .data.items on this result. And then we can call the function. All right, let's go ahead and run it. Oh, I forgot one thing. We actually need to throw this 300 into a big int. Okay, let's run it again now. And as you can see, we have our response here. This response is pretty detailed. We have the time in which the block was signed at, the block height, TX offset, log offset, the hash, the raw log topics. You can see all it here. It's pretty detailed. And then we, of course, have the parameters in an array that we can call separately. But this is pretty cool. So in just 21 lines of code, less if you were a little bit more efficient and intelligent with the way that you formatted it, we have a very detailed response with moderate speed and efficiency. You can find all 3 of these technologies, RPC nodes, subgraphs, and the Covalent API natively on Chainstack. To learn more about creating and deploying subgraphs, check out the Byte-Size BUIDLing series on the Chainstack YouTube channel. And you can also find the thread/text version of this video linked below.